Hello everyone, welcome back to the SAP2000 basic course. In the previous lesson, we learned how to apply loads to the frame and how to define load patterns and load combinations. In this lesson, we are going to learn how to run the analysis and how to read the analysis results, including deformed shape, shear force diagrams, bending moment diagrams, and support reactions. From these results, we can understand how the support and the end release affect the behavior of the structure. Let's begin today's lesson. First, open the model from the end of the previous lesson and maximum the left and the right view windows. Next, we will run the analysis. You can simply click the Run Analysis shortcut button on the toolbar. Click Run now. After the analysis finishes, you will see a deformed shape on the screen. On the tab at the top of the window, you will see the label like deformed shape, dead. Dead means this is the deformation caused by the dead load case. But what we really want to see are the deformation results under the load combinations, such as combo 1 and combo 2, which includes combination of dead load, live load, and wind load. So go to Display, Show Force and Stress. Show deformed shape. The default load case is dead, but we want to change it to combo 2. Combo 2 includes dead load, live load, and the wind load together. Select combo 2, click Apply, click OK. Now, this deformed shape represents the deformation under the all loads combined. First, let's compare the behavior of the simply supported beam and the fixed end beam. You can close the 3D view window for convenience. On the simply supported beam, the mean point deformation is about minus 0.0105 meter. On the fixed-ended beam, the mean point deformation is about minus 0.0019 meter. So clearly, under the same uniform load, the mean point deflection of the simply supported beam is much larger than that of the fixed end beam. The deformation diagrams help us quickly judge whether the model makes sense. If some joints deform too much, or in the direction that looks wrong, you should go back and check the supports and the loads. Next, let's look at the shear force diagram. Go to Display, Show Force and Stress, Flange Cable and Tendons. For case combo, choose combo 2. For the component, we will display the shear force, so choose shear 2. For the scaling of diagram, we will just leave it as automatic. Under options of diagram, we have two choices: one with the force, one with only the shape of the diagram, and one that also shows the values. I usually check show values so that the values are displayed on the diagram. Click Apply. Then click OK. Run it to take a close look. For a typical beam, the shear force V2 is usually largest in the end, and it drops to 0 at the mean point under the uniform load. Next, let's look at the bending moment diagram. Use the same command. We keep most of the settings unchanged. This time, in the component field, choose moment N3. Leave the other options as they are, then click Apply. Click OK. Now, let's first compare the simply supported beam and the fixed-ended beam. Run it to see clearly. In lesson 6, we release the end moments of this beam, so it behaves as a simply supported beam. The maximum mean span moment here is about 25.09 kilonewton. On the fixed end beam on the right, the mean span moment is about 7.4 kilonewton m, which is smaller than simply supported beam. Next, let's check the support reactions. Go to Display, Show Forces and Release, Stress. Choose Joints. For the case combo, select Combo 2. For display type, choose Arrows. You can also enable labels. After you click Apply, the reaction force at the 4 supports will be shown on the screen. Run it and take a look. At each support joint, you will see colors around arrows showing the direction and the value of the reaction forces. Look at the joint which with the spring support in the middle. Because it can deform a bit, its reaction is slightly smaller, around 42.72 kilonewton. At the fully fixed support, the reaction might be around 53.7 kilonewton, which is larger than the reaction at the spring support. This helps us verify how the loads are shared among the supports and whether the support conditions have been set correctly. This is the basic procedure for checking support reactions. In this lesson, we learn how to view analysis results, including deformed shapes, shear force diagrams, bending moment diagrams, support reactions. We also compared the behavioral difference between fixed end beams and simply supported beams. In the next lesson, lesson 9, we will move to steel frame design. We will let SAP2000 use design code to automatically check and size the steel beams and columns. That's all for today's lesson. If you enjoyed today's lesson, please remember to share, subscribe, and turn on the notification bell. See you in the next class.